All right, this next week we're starting stoichiometry. This is when we're going to use what we learned months ago. Converting grams to moles, moles to grams, and then we went to molecules as well, but we're not so much going to molecules or atoms this time. So on this worksheet, I'm going to do a couple from each section. I'll start with number 1. So what you're going to do is you're going to, on a separate sheet of paper, you're going to do the work. And then when you submit it in Schoology, you're going to take a picture of your work and submit it in Schoology that way. I don't want just the answer on this Word document. I want to see your work. So the purpose of stoichiometry is if you start with grams or moles of one compound, let's say this compound right here, you can figure out how much you're going to get of a product, lanthanum hydroxide, or vice versa. So it is really useful in industry when if the product that you're trying to make is lanthanum hydroxide, then you can figure out, this is what chemists do, how much they need of water and lanthanum oxide to do the reaction. So we're not wasting any reactants or anything. So to set this up, you always start with what they give you first. So 2.5 grams of lanthanum oxide, and you have to put the compound each step or you won't know what compound you're talking about. So the first thing you do is when we converted grams to moles or grams to molecules, moles was that bridge between two different units. This is the same case here too. So the step that you always want to do is convert to moles. So if you watch the stoichiometry video, it's all about ratio. So if you look at the ratio between lanthanum hydroxide here and lanthanum oxide, it's a 2-to-1 ratio. Okay, so that's what we're using. That's our conversion unit to go from this compound right here to this compound. So that's kind of like how many cups are in a quart. That's like how you get from quarts to cups. This is how you go from lanthanum oxide to lanthanum hydroxide by looking at the coefficient, the ratio. So we are converting lanthanum oxide to moles because then we can use that coefficient to go from lanthanum oxide to lanthanum hydroxide. So to convert lanthanum oxide to moles, you've done a problem like this before. Remember, you put 1 mole equals so many grams of lanthanum oxide. So lanthanum oxide is what we have here, so it's important to put the compound. And I'll show you in the next problem. You can label these A, B, and C, so you don't have to write this compound. It just saves you just have to write 1 letter. So to get this mass, remember, I always ask you, where do we get grams? On the periodic table. So on your computer or on your phone or something, have the periodic table pulled up so you can see the mass of them. So we are taking the mass of lanthanum and oxygen. Oxygen is 16, and if you look at the subscript right here, there's 3 of them, so you have to multiply 16 by 3. Lanthanum, it's a hard one to find. It's number 57 on the periodic table. So the mass underneath that is 139. And the website I'm using is ptable.com. And the subscript by lanthanum over here is 2. So you're going to multiply it by 2. So in your calculators, I need to get mine on my phone. You got 139 times 2. That equals 278. And 16 times 3 equals 48. So you add 48 and 278, and that's going to give you 326. So that's the mass of 1 mole of lanthanum oxide. So we're still talking about lanthanum oxide up here. We're not to lanthanum hydroxide yet. So to go from this compound, lanthanum oxide, to lanthanum hydroxide, this one right here, because that's our question mark, that's when we use the coefficients. So remember, the whole process here is if you have grams of lanthanum oxide here, grams of lanthanum oxide goes on here. So moles of lanthanum oxide, so moles of lanthanum oxide go down there. So moles of lanthanum oxide. And we're converting to moles because that's our ratio. The mole ratio is the coefficient of lanthanum hydroxide right there. So this step, when you have mole over mole, that's when you look at the coefficients. So the coefficient right here, whoops, thought I would highlight it. Guess not. Is 2. I scribbled it out. So that's going to be for lanthanum hydroxide. And then over here in front of lanthanum oxide is nothing, so it's a 1. So that's how we go, because these units will cancel out, as did these ones. That's how we go from moles of lanthanum oxide to moles of lanthanum hydroxide. And I know we're trying to get grams, but we have to go to moles to be that bridge between one compound to the next. So the last step, and this is the longest step problem. I should have done an easier one first, but this happens to be number 1. So the last step is going from moles of lanthanum hydroxide to grams of lanthanum hydroxide. So since you have moles up here, moles go on the bottom. And then grams of lanthanum hydroxide goes on top here. So 1 mole of lanthanum hydroxide, because these are all going to be 1s unless you're at this step right here, which is a mole to mole ratio, which is coefficient. So this, remember, like the denominator equals the numerator equals denominator. So if you have 1 mole of lanthanum hydroxide, that's the mass of lanthanum hydroxide right there. So again, we have to add these up. We already found the mass of lanthanum. There's only 1 of them this time, so 139. Whoops, I wrote this wrong. Whoops. Get rid of that. The 3 is outside of the parentheses. Whoops, went too fast. So this time this 3 distributes. So there's 3 oxygen and 3 hydrogens. So we already found the mass of 3 oxygens up here, which is 48. Then we need the mass of 3 hydrogens. 1 hydrogen is 1, so it's just going to be 3 grams there. So add all that up. 139 plus 48 plus 3 will give you 190. So that is the mass there. So how to plug this into your calculator? You take 2.5 divided by 326, so 2.5 divided 326. Then you multiply by 2, because the 1 isn't going to change your answer, so just kind of ignore the 1s. Anything on top you multiply, anything on the bottom you divide. And the last one is 190, so you multiply by 190. Your answer is going to be 2, and I'll just keep that point there, 2.9 grams of lanthanum hydroxide. All right, so write down this on, just do number 1 and write down the work. You don't have to do the equation again when you do these problems. Number 2 is exactly the same way. So you start with this, and then you have to convert to moles, do the mole ratio, 5 and 2, and then convert to grams again. So let's move on to the other type of problem. So this is grams to grams. Whoops. And if I go to the next one, the next category is grams to moles. So I will start with my what you're known as, which is 6.2 grams of sodium oxide now. Oh, again, I told you that instead of writing out the whole formula, you can just label the 2 that you have. So let's call this one A and this one B. So it saves you writing more letters. You know, it's not that big of a difference, but some of them, it might be really long formulas that it might be a pain to write. And sometimes students don't write the formulas, so if I can help you know which compound you're talking about by just putting letters, that would be great. So this is B, and we're going to A. So first thing we do, when we start with grams, we have to convert to moles to get to another compound. So since I have grams of sodium oxide on the bottom, grams of sodium oxide, I'll put B, because this is our B compound, is on the bottom. Saves me writing Na2O. Then we're going to moles of B. And remember, moles, you can write MOLE or MOL. So 1 goes by moles, and we're trying to find the mass of 1 mole of sodium oxide. So look on your periodic table for sodium, which is 23. There's 2 of them because the subscript is 2. So 2 times 23 will be 46 grams. And then oxygen is 16. So 46 plus 16 is 62 grams. So that's the mass of 1 mole of sodium oxide, 62. Okay, so now we converted from grams of sodium oxide to moles. Now that's our bridge between this compound, sodium oxide, to sodium chloride. So now we can use the coefficient, which is the mole ratio. So since I have moles of B on top here, moles of B go on the bottom. And then moles of A, which is our sodium chloride, goes on top. So the coefficient in front of sodium oxide is a 1, and in front of sodium chloride is a 2. So we're going to stop there because we just are trying to figure out moles. We're not trying to find grams, so we don't have to convert sodium chloride to grams. So in your calculator, you put 6.2 divided by 62 times 2. That's going to give you 0.2 moles of sodium chloride. So don't put A for here, put the right formula for your answer. So you're going to do number 5 the same way. You're starting with grams, and you're trying to get to moles of another compound. Let's move on to the next type of problem. And that is going moles to moles. So moles to moles is the easiest one, and that's the last type of problem. Should probably do those ones first. So you have 4.2 moles of B, which is vanadium. So I'm not going to label them A or B because they're really short compounds. So I think you can write a B instead of A. That's not going to be too hard. So we already have moles, so we're not going to convert B to moles because there's already a mole. So we can go straight to the mole ratio, 4-to-5 ratio. So we'll put moles of vanadium on the bottom and moles of oxygen on top here. So in front of the V, there's a 4, so you're going to put a 4 there. In front of the oxygen, there's a 5, so you're going to put a 5 there. So it's only multiplying by one fraction. So in your calculator, you take 4.2 multiplied by 5 divided by 4. And your answer is going to be 5.25 moles of oxygen. So that's the easiest one. Should be number 1. But then the last one is moles to moles again, and you're going to do it the same way. So refer to that video of stoichiometry if you need more help. Message me on Schoology. I can do like a Zoom video, or I can do another one of these videos to show you a problem if you get stuck. Okay, so good luck.